Stop.
All right, so today we're going to continue our conversation on multiplication and division of whole numbers by examining the concept of how to illustrate division. And really, when we talk about illustrating division, we're going to talk about illustrating using two different models. First one would be the rectangular array, and the second would be the area model. Now, one of the things that I do want to kind of point out is the rectangular array is specific for a specific set of numbers, whereas the area model can handle larger numbers. So in saying that, rectangular array, which we'll take a look at one, and you've seen this before, and it's not always just blocks. It could be dots. It could be anything with really rows and columns. Typically, we want to use a rectangular array in a single digit by single digit multiplication and division, which I'll show you today. Now, in order to really open this conversation up, we really need to understand that our division and multiplication, as we examine these two operations, that they are really connected to one another. We'll continue to tease this out throughout the year. In fact, we would use the word their inverse, which means the kind of opposite of. And it's much like addition and subtraction. The inverse of division is multiplication, therefore the inverse of multiplication is division. And what that means is, and just to give you an addition and subtraction kind of reference, kind of get your mind thinking, 4 plus 2 equals 6. And then I could say, well, the inverse of that would be 6 minus, and I could take either of the add-ins, but I could say 6 minus 4 is going to give me the difference of 2. And I can use actually subtraction to check my addition, and likewise addition to check my subtraction. Well, we know that that same capability is able to be used with multiplication and division. Now, with the area model, we're going to get into bigger numbers, but we'll kind of start this conversation using an array. And I have an array here that we typically would look at it, and we see in the array that we've got rows which run from left to right or right to left, and we have columns that run up and down. Now, we could look at this as 3 columns of, and that multiplication sign tend to go hand in hand, of 4, which would be 12. Or I could say, well, there are 4 rows of 3, which would be 12. And so I could see that in this diagram, in this model. I can see that. But what if I said, well, what division sentence would this represent? Imagine if this were a pan of brownies that's been cut up. Right now, it is 12 pieces that are put together. But I could still take this and divide and say, well, this is 12. And if I'm dividing them into rows, I'm dividing them into 4 rows. How many would be in each row? I could say there are 3. Well, if they're also 12 and I'm dividing them into 3 columns, how many are in each column? Well, I would say 4. So all of a sudden, you can start to see evolve are these 4 equations that all really are interchangeable with one another in terms of they're able to represent the same model. So a division sentence or a division equation representing this model would exist over here. Here is my division representing this. Both of these could speak into this. So we see division right here. Now, likewise, we see the multiplication over here. Look at their spelling. I'm glad I'm a math teacher, right? Multiplication is right there. And so we see that. So we talk about being able to illustrate. Now, be mindful, and I really can't push this enough, is that we're really talking about using to show what's going on, not to solve through our models. At this point, we're going to use an equation or an algorithm to solve, or even with these numbers, really mental math to solve. But what happens when the numbers get larger? So let's talk about if we have the number 1,104 divided by 24. Now, the first thing is I'm going to tell you is we're not going to get into using area models to solve division. I know that in previous grades you've used the area model for multiplication, and you still may be using that for multiplication. But if you go back to the beginning, when we really come back here, is we really want to, zone in on is that the I can illustrate. We want to show what's going on. This does not mean, just a misconception. It does not mean to solve. We're not looking to come here to solve with this. We're here to show our understanding. So when we come here, one of the things you're going to have is you're going to go ahead and have the quotient. So you're going to be given an equation. You would say, well, can you show me how this would work? Now, the first thing that I would want to do is know, well, can I take it and find the inverse? I'm going to first flip this from division to multiplication. And all I have to do there is take my divisor and my quotient and turn those into factors. And then my dividend becomes the product. The same concept that was going on over here, just here, it's bigger numbers. Now, in doing so, the last thing we need is 24 rows and 46 columns, creating 1,104 little blocks, because that would be incredibly large. But what we're going to do is we're going to come in and we're going to draw a box. Now, on our box, we're going to take, and it doesn't matter, the commutative property gives me a little freedom. I prefer to take the largest number, and I'm going to expand it on the top line. And then I'm going to take the other factor, and I'm going to expand it down the left side. Now, I'm going to, wherever there is a plus, I'm going to take and I'm going to cut it and draw a line from left to right there, and here's another plus sign, and then up and down. So I kind of created this window. Now what I'm going to do, let me change some colors here to help us out here. This here is going to represent 20 times 40. Now only what I'm writing in yellow is what I would expect you to write. So we're going to say this is 800. And then here, 20 times 6. See what I'm doing? I'm looking at the box. Whatever's in the box is kind of where things meet. So 20 times 6, I'm going to come and say, well, this is 120. Then here is 40 times 4, which would be 160. Then this one is 6 times 4, which is 24. And I know all these equal up to be, if I've done my math correct. Now, if I've done the multiplication correct, I know that this equals 1,104. And this might be something I want to step out aside and double check and just add the numbers up. And it should, when I add these up, equal this number. So 0 plus 0 plus 0 plus 4 is 4. 6 plus 2 plus 2 is 10. Regroup. And 1 plus 8 is 9, 10, 11. And sure enough, if you look there, you've got the same product, which would be the quotient. So with the area model, step 1, turn it into a multiplication, find its inverse, and then use the area model to show when you get a number this big. Again, the big thing that I would stress when we talk about this is that we're not using this to illustrate, or I'm sorry, we are using this to illustrate, we're not using this to solve. So that is how we illustrate the division using rectangular arrays and or area models. My number one, well, I have two takeaways from this. Number one is attention to detail. Read the question. If it's asking for multiplication, when you're looking here, make sure that you give it a multiplication. And then on this one here, when you're asked to do an area model, don't jump in and just start creating a model out of this division sentence. You have to get to this step right here. If you don't flip it and find the inverse, you're going to have a really large box with a really big number. So that's illustrating the division by using rectangular arrays. Good luck.